and it then starts recording, and then it opens up the writing pad. The reason I did this is because one time I forgot to turn the microphone off, and I thought, if I just had one way to do everything I need to. But none of you care because none of you want to do programming, right?
It's pretty cool.
It is, yeah. It's handy, yeah. Okay, the vector triangle. There you go, write this down. This is lesson 3, the vector triangle. So I enjoy writing programs, because I have my own website as well. So I do PHP, Python. Do you know these languages? PHP, you know? Heard of it?
No.
Python?
I've heard of it.
Okay. And I think nowadays, if you're doing engineering, you'll have at least one semester of one class of programming in one language, as a minimum, because, it's 2016, yeah. So even though you're all doing engineering, it is, yeah. Even though you're all doing engineering, I feel like you'll have one semester of one class that has programming in it. Like when I was studying maths, I had one class of programming, and it wasn't. I don't think it was an optional class. You have to do it, And I feel it'll be the same. Compulsory. I think this will be the same for you. Yeah. Just a basic class in programming. Yeah. I think just because it's so important nowadays. Yeah. Right, the vector triangle. So this again is just drawing vectors. Now, we can add vectors together, and there's many ways to add them together, and one way to add them together is by using what's called a vector triangle. So if we have two vectors, we can add them together using a vector triangle. So for example, consider vector A and vector B. The sum of the vectors, which we call the resultant vector. Now you might want to write that word down. The word resultant vector means the vector you get when you add two vectors together. It's like the answer.
The addition of two vectors is called vector.
Yeah. And in fact, it doesn't even have to be the addition, and it doesn't even have to be two vectors. It's almost like the final form, the answer.
Does it have to be some?
It doesn't have to be.
Yeah, it's like vectors can be added together by, if you want to add together, how will it?
We'll do that, don't worry, I'll show you how. So resultant vector. Now, I didn't make this point in the last class, but I'll make it now. You see these three vectors?
Yes.
These are all the same vector. Even though they're drawn in different places, they're all the same. Because a vector has two things. What are the two things it has? A magnitude and a direction. Which way does this point? North, north, north. Up, yeah. And they're all the same length. So this makes them all the same. So it doesn't matter where you move it. Okay. So if you have two vectors, like for example, vector A is here, this we'll call A, and vector B is here, this we'll call B, and you want to add them together, you can jump back to the start. You can add them together like this. What you do is you take the tail of B and move it to the head of A. So here it's like you would take this vector and move it to here. But you don't change the direction and you don't change the length. So you just move it and put it here at the head of A. And then what you do is draw a triangle. So there's the A, there's the B, and then you draw a triangle, and this is called the resultant. This is the vector A plus B. So it's quite easy to add them. Like if we've got a pen, if I just take this pen here. So here's one vector, here's another vector, put it like this, and all you do is you move this over to the head of the other vector, and then if you can imagine the triangle,
Yeah.
so the answer would be that way.
Yes.
Yeah. So, not too difficult, and I described what to do there, but really, if you have the picture, then you should know what to do. So, if you can draw this picture, please.
This,
Yeah.
I heard this, the first time, the vector triangle, and
Yeah.
it's like the same, but we say it's the head to tail rule.
The head to tail rule, yep, that's
It's the
another
same,
thing. It's the
I
same, yeah, same idea.
Everything is the same, that just the name is different.
Yeah, head to tail, yeah. I don't know, that kind of sounds very American to me. Because you're American? No. But you studied in English, or?
But I have studied Oxford, books of.
Oh, Oxford, okay, yeah. In fact, in Ireland, this is not what we use in Irish high schools. We use a different... Oh no, we don't even use the triangle. We do it a different way.
Oh.
Yeah. But I don't need to show you that because it's not on the course. It uses a parallelogram. Have you heard it? Four sides?
Yes, I heard. It's like this.
Yeah.
It's this and.
But we don't need that. Okay. Did you draw this? Have you seen this before?
Yeah.
Andy?
Yes.
What's your t-shirt say?
With this, Rhode Island Scrooge is everywhere.
Say that again?
Rhode Island Scrooge.
Rhode Island.
Yeah.
Okay, how American. Right, continue. Now, we can add two vectors together by putting the tail to the head, but we can also multiply a vector by a scalar. So for example, I could take a vector like A and multiply it by 2. Now what the heck do you think does that mean? To multiply this vector by 2?
Make it like.
Yeah, make it, precisely how?
Like.
By the magnitude of that one, we will multiply.
Yeah, but give me a simple word in English. If you multiply it by 2, you're right, the length gets bigger. The length doubles. Yeah, and if you multiply it by 3, triples. Yeah. So you can multiply a vector by a scalar, and when a vector is multiplied by a number such as 2, as an example, it doubles its length. And likewise, if it was multiplied by 1/2, what happens? Half its length. Half its length. Now, what about if I multiply by -1? What do you think happens?
Well, that's less fact.
Yeah, but yeah. If you have a vector and you multiply it by -1, it just gets flipped around. Yeah. So if you multiply a vector by -1, it will flip 180 degrees.
Yes.
Yeah. But I think you probably all knew that already, did you?
Yeah.
Do you need to write anything down from this? I don't think so.
Multiplied by -2.
Yeah, what happens? Tell me.
Strength and.
Yeah, that's it, yeah. It flips and doubles.
Yeah.
Now, of course, we can add, subtract, multiply, and divide scalars. This is what you learn in elementary school. Of course you can do that. 2 plus 2, 2 times 2, of course. Yes, all that stuff you can do. We can multiply a vector by a scalar, like we were talking about. We can add or subtract vectors. Now, this is interesting. If I draw A and I draw B, how can I do A minus B?
If it's 3 and it's 2, you will -2 and.
Yeah, but they're vectors, not numbers.
So their size will be,
No. I'll tell you. Watch carefully. You change this into A plus minus B.
Okay.
Because the minus B is this.
Yeah.
So you just stick that
Same direction.
onto the A, and then this is the answer, A minus B. Yeah. So you see, the trick is to think of this as plus minus B, and the minus B is just flipped around. That's the trick. Yeah. Okay. So we can add or subtract vectors. So this is what we can do. What we can't do, we cannot multiply two vectors. Not really. We can, but we don't do that. So for physics class, we can't really multiply vectors, but we kind of can, sort of, later. But for now, we'll say we can't multiply vectors. And we definitely cannot ever divide vectors. So you can never ever do A divided by B. Never.
So it's not just for that.
Not just for now, for life. Okay. So that's what we can't do. Right, so I think we have two questions. We've got a little bit more to do. So I want to do this one with you. I think I'll have you write this down and then we'll do it together, okay? So just write this question down, please, and we'll do it together. Now, if you want, you can leave some space between them for the answer, okay?
So tomorrow is the bus strike?
Today Thursday or Wednesday?
Wednesday.
I don't think so. I think the strike's Friday.
Yeah, it's
Friday.
So, well, Friday and Saturday.
The last week it was Thursday.
Last week was Thursday and Friday. Yes, it's different days. Yes. Well, that's not too bad, I suppose. Well, you're fine. You live on campus, so you've nothing to worry about. And how are you going to get here?
I live in Whitehall Road, Dublin 6.
Yeah. Now, what are you going to do?
I'm gonna come by taxi or by walk. Maybe take 40 minutes. Yeah.
By walking?
Yeah.
I think you should walk. I
Yeah.
think it'll be extremely difficult to get a taxi.
Yeah.
Everybody will be trying to get a taxi. Yeah. What about you?
During Dublin 14,
What's Dublin 14?
Churchtown.
Ooh, what are you going to do?
Tennis, Joe, maybe.
Yeah. Bicycle, maybe.
I live in Henry Street.
Ah, you can walk. You can walk. Yeah, and for you?
I live in Hughes Road, Dublin 12.
What are you going to do?
Well, I have friends of mine who live nearby. We'll probably get a taxi all together. We've done that before.
Okay.
Right, so,
Yeah. You'll do it as a group then?
Yeah.
Okay. Well, how long would it be to walk?
about an hour.
I will take
Oh,
it.
that won't
I
fit
will-
you.
Well, we'll see.
No, I
Yeah.
will take taxi because I don't know the place. I
Oh,
don't
you-
know the country.
Oh, yeah, okay. You might walk.
I want, like, if I know the places, I can walk, but.
But sure, don't you have Google Map or GPS on your phone?
I have, but maybe it will, like, send you another place.
You need to trust it.
Yeah. Don't worry. I think if you put Griffith College, South Circular Road, I think you'll be safe. I think you'll be okay. All right. Do you have these nearly? So I'll do them now in a moment when you're ready. Yeah? Okay. Okay.
What about the bank accounts?
Yara, when are you doing that now? I thought you're doing something with Sylvia, is it, or?
I think that the bank is going to come.
That's it. Is that today?
Yeah,
there was
tomorrow.
some are saying today and some are saying tomorrow.
Yeah.
Oh, well, maybe it's done in two halves. I don't know. What did Sylvia tell you?
She told that tomorrow they will come.
Yesterday the principal came in the bench club, so she said on Thursday. And
On Thursday,
yeah,
okay.
the guy was saying that her teacher has said that it's on.
Well, if the principal said Thursday, it's probably Thursday then. Yeah. But anyways, you don't need to worry. They'll come to the school, so
Yeah.
that's okay. All right, can we have a look at these now?
Yeah.
Look. So the first one, 5 kilometers east and 5 kilometers per hour north. So let me draw this one. In red, this can be 5 kilometers east, and then the other one is 5 kilometers per hour. I'll just draw it here. 5 kilometers per hour north. Okay, so that's okay, isn't it? You can write that down. This is part A. Now, part B. Let me see what you think. Can you add these vectors?
Yes.
And how would you add them? Using what? What's it called? The vector triangle.
The
Yeah,
vector
vector
triangle,
triangle, yeah. And the answer is no. You can't add them. Why not?
Because there's time.
Because B is a scalar?
No, I think you have it. The units are different.
Oh, okay.
Now remember, that rule I said about they must be the same units to add together,
Yeah.
that is still true for vectors. So in fact you can't add these together because they're not the same unit. So the answer is actually no. So what I want you to learn from this is that vectors also have a unit. Yeah? Okay, continue? Yeah. What is the vector TB where T is 2 hours? Okay, so what you have here now is T is 2 hours, and I want to know what TB is. And which one did I say is B? The one that's going north. So this is vector B. I'll do it in green. This is vector B, and this is vector A. Okay, so what will the vector TB look like? Well, what's T?
Time.
I mean, what number value? 2.
2.
So if I multiply B by 2, what happens to it? Doubles, yeah. So the answer for TB would be, something like this. This will be TB. It's twice as big.
10? Is it 10?
It'd be correct. It'd be 10. But what would be the unit now?
Kilometers per hour.
Now, it'd just be kilometers because
That's divided.
the B is kilometers per hour, and what unit is the T?
It's hour.
Is hours.
So it's
I would say you can't put the hours together, right?
Yeah, so it's just 10 kilometers. Yeah. So that's TB. Okay, so that's C. What's next now?
draw T.
Oh, okay, that's D. Yeah. Okay, what's part E asking me to do?
So it's asking what is the dimension of T. So that's
Oh yeah, there it is there. Well, the dimension would be of length. The unit is kilometers. Okay, what's E?
draw the
Draw the
result of
result
A
of
and B.
A and B and TB.
A plus TB.
Yeah.
Okay. So if I zoom out again, we have to use our triangle. This is A. Oh. squish it here. This is A. This is TB.
And that's
So now using the triangle, this is the answer. A plus TB vector. Using the triangle. Because this is A and this is TB. This is 5 kilometers and this is 10 kilometers. What do I ask you anything else? Yeah. So the last one, F. I'll give you a minute to think about it. What does this vector represent? Yeah, but like as a story.
Displacement of maybe something from here.
This is displacement, you're right, yeah. But if you kind of look at all the letters, we started with A, yes? And then we added TB. T is in the unit of time, yeah, hours, and B is kilometers per hour. So if you look at this, what do you think it represents if you were to give me a story? Well, I'll tell you. What happened was this. We started off with A, so that's like the displacement of a person or whatever. And then we had this vector B. And the B vector, or whatever it was, I think I have this backwards, sorry. We started off with A. This is A. And then vector B was something like this. This is B. And what was the unit for B? Kilometers per hour. So that's like a velocity. We multiplied it by T. What's T? A time. So what do you think that represents?
acceleration.
Not quite that. If I said 5 kilometers per hour north for 2 hours, how far have we traveled? 10 kilometers. So this TB represents the distance traveled after 2 hours. Going, speed. The speed was 5 kilometers per hour, the velocity was 5 kilometers per hour north. After 2 hours, you've traveled 10 kilometers north. He did not start at the beginning. Where did he start? He started 5 kilometers east. So this, as like a story, would be, a man 5 kilometers east, then moves north for 2 hours at 5 kilometers per hour.
Well, what is the closest?
What is the displacement? What is the final displacement? So the final displacement is this.
He moved north for 2 hours at 10 kilometers.
No, it's 5 kilometers per hour. So in total, he travels 10 kilometers. So if you want to rephrase it, you could then say he moves north for 2 hours at 5 kilometers an hour, or you could just say he moves north
For 2 hours.
10 kilometers. Yeah, if you didn't want to use the time. Yeah. You get the idea? Yeah, okay. Right, so that's interesting. Okay. We have one more example, I think. Yeah, one more example. Okay, so again, if you want to write this down, and you can leave a little space for the answer then. And then I think there's just one more slide. Yeah, and then that's it. Okay. Alright, so if you can write this one down. Oh, yeah.
The answer for F is displacement, is it?
You could give it as a sentence. You could say, as a story. A man starts 5 kilometers east. Or no, if you want, you could say a man starts at A and then travels B for T time. That's the simplest way to put it. I don't even need to take the attendance. I do have everybody. Nobody has left except for Isaac. Yeah. Iyad. And Andy. And Adnan. And Isaac is gone. And Mir, is that what you go by?
Yeah.
Is that what the other teachers call you? Just
Yeah.
Mir, yeah. And then Mahmoud. Is that what the other teachers say? So Mahmoud, Mir. Yeah. Adnan, is that what the other teachers say? Yeah. Okay. Last year I taught maths and physics to the engineering students, so I'd see them for 12 hours a week. So it's like every day. But I think I'll see you on Friday for computer class, ICT. Yeah.
What time are you studying?
Haven't decided yet. I need to have a think about it.
You are a goals leader too.
Oh no, I decided I don't want to be that. That's too much stress. Course leader like Lorraine or Connell or something. Connell is your course leader for engineering.
Yeah.
And who's your tutor? Isabel, yeah. This is a stressful job. Because they have to worry about you. Yeah. Do you know, why isn't he going to school? Why isn't he doing his homework? Okay, nearly ready? Yeah, it won't make sense until I do it. Yeah, but it will help you. You'll see it in a minute. Oops, there we go. Okay. Yeah? Yeah? Okay. Did you write down the information here? Yeah, okay. So I'll try and draw it here. Right. So what's the first part? A man walks. Oh, hang on. All right, hang on. Let me just make a beautiful something. Oh, so beautiful. Right. This will be helpful. Right, close enough. Right, so he walks 5 steps north, and then what does he do?
5 steps west. 5 steps west.
Okay, so I'll put him here. So first he walks 5 steps north. 1, 2, 3, 4, 5. Next.
1 step. 5 steps east, west.
East, west.
5 steps.
5 steps west. Yes.
Yeah.
Okay. 1, 2, 3, 4, 5, and then
1 step east.
1 step east, and then
Then 1 step south.
1 step south. And is that it?
And 9 steps.
Yeah, and then he finishes here then. Great, okay. So what's the first question then?
What was it every?
East of the journey.
Right, so this formula for speed, do you remember it?
Yeah. Distance upon time.
Distance over time. So what's this distance traveled? It'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Yeah.
So 12 steps, and the time?
9.
9 seconds. So what's that? 1.33 steps per second. Now, does that make sense? That's it, yeah? Okay. Okay, what's the B part, Andy? When you're ready. Or not ready. What's part B? What do I ask him to be?
Draw the
4 velocity
vectors.
Ah, well, I've done that. There they all are in red. These are all the velocity vectors. Or rather, I suppose, if you want, it's one vector. This is the first one. This is 5 steps. I know it doesn't matter. No, that's it drawn there. So maybe I should have asked you to do that first. Okay, C. Now the displacement one's a bit more interesting. So first he's here, then he's here, then he's here, then he's here, then he's here, and then the next displacement vector will be this one. You know, and then the next one, he's here. You see what's happening?
Yeah.
The displacement vector points to where he is.
Those are 4 displacement vectors. Is it just
I suppose I'm doing it for each step actually, yeah, sorry. So at the beginning, he's here. Then after the first part of his journey, he's here. Then after the next part, he's at the end here. Then he's here, yeah, and then the last displacement vector is that one there.
Yeah.
So they're the 4 displacement vectors. Okay, so that's part C as well. And what's next, part D?
What is the magnitude and direction of his final displacement vectors?
Right. And that's the hint. So if you look at the final displacement vector, that's from here to here. What's its magnitude? Well, here's my hint. I said this is a triangle. Can you see that?
Yeah.
I'll put it in red or something. How big is this side? 4 units, and this side 4. So 0.65. So the magnitude is 5.65 steps. And what's the direction? Well, it's actually north. It's exactly northwest, because it's perfectly 45 degrees. So it's 5.65 steps northwest is the magnitude and the direction. Is there another part?
Yep.
What's the last part then?
Therefore, what was his average velocity?
Fine, so what's the formula for velocity? Do you remember it? It's displacement over time. So it will be 5.65 divided by 9. Yeah. Steps, and that would be per second. And what's the direction? Northwest. So what answer is that, please? 5.65 divided by 9.
0.62.
0.67 steps per second northwest. Yep. Okay. Right. Last thing to say, vector A and B, they're commutative. What does that mean?
A plus B, B plus A.
Exactly. A plus B is the same as B plus A. Okay, so it doesn't matter if you do A plus B or B plus A, you get the same answer. Okay? Right, so again, the homework is similar to what we did. The first part, you need to draw some vectors. Part B is a little bit of a story, and part C is a little bit of a story as well, like the examples we did. When's our next physics class? Is it tomorrow, or is it later? Is it Friday?
Friday.
Oh, is it? Okay. That's plenty of time. Plenty of time. So if you have this homework for Friday then, okay? Yeah. Andy, can you log into Moodle?
Yeah.
Yeah, it works. And can you see the physics page?
Yeah.
Okay. You can take the picture if you want, but it's on Moodle as well. And even if it's not on Moodle, if you watch the video and just pause it at the end, you can get it.
Why is it so colored?
Yeah, you might want to just open it on Moodle or watch the video on YouTube. Okay, we'll finish. Are you in this room next? Or you got break now?
We got break.
Okay.